In the industry, reactors are one of the most important equipment to create a desired products from the raw materials. The design of a certain reactors are crucial. There are three types of basic reactor, which is continuous stirred tank reactor (CSTR), batch reactor, and lastly, plug flow reactor (PFR). Today, we would like to focus more on PFR. PFR or tubular reactor consists of long hollow tube in which the reactant will flow in axial direction in the shape of plug, as shown in figure. So, let's move on to our objectives of the experiment. First, to carry out a saponification reaction between sodium hydroxide, NaOH, and ethyl acetate. Second, to determine the reaction rate constant. And lastly, to determine the effect of residence time on the conversion. Material used are 0.25 molar hydrochloric acid, 0.1 molar sodium hydroxide, 0.1 molar sodium acetate, and deionized water. While the apparatus used are: first is burette, next is conductivity meter, lastly, plug flow reactor. For the procedure, first, prepare the following solution: 1 liter of sodium hydroxide, which is 0.1 molar, 1 liter of sodium acetate, which is 0.1 molar also, and 1 liter of deionized water. Next, determine the conductivity and sodium hydroxide concentration for each conversion values by mixing the following solution into 100 ml of deionized water. For the first one, 0% conversion, we use 100 ml sodium hydroxide. 25% conversion, use 75 ml sodium hydroxide and 25 ml sodium acetate. 50% conversion, we use 50 ml sodium hydroxide and 50 ml sodium acetate. 75% conversion, we use 25 ml sodium hydroxide and 75 ml sodium acetate. And 100 conversion, we use 100 ml of sodium acetate. First, ensure that all valves are initially closed except valve V4, V8, and V17. Second, prepare the following solutions: 20 liter of sodium hydroxide, 0.1 molar, 20 liter of ethyl acetate, 0.1 molar, and 1 liter of hydrochloric acid, 0.25 molar for quenching. Third, fill the feed tank B1 with the sodium hydroxide solution and feed tank B2 with the ethyl acetate solution. Fourth, fill the water jacket B4 and preheater B5 with clean water. Fifth, turn on the power for the control panel. 6. Open valve V2, V4, V6, V8, V9 and V11. 7. Switch on both pump P1 and P2. Adjust P1 and P2 to obtain flow of approximately 300 ml per minute at both flow meter F1-01 and F1-02. Make sure both flow rates are the same. 8. Allow both solution to flow through the reactor R1 and overflow into the waste tank B3. 9. Open valve V13 and V18. Switch on pump P3 to circulate the water through preheater B5. Switch on stirrer motor M1 and set the speed to about 200 RPM to ensure homogeneous water jacket temperature. First, perform the general startup procedure as mentioned before. Second, open valve V9 and V11. Third, Allow both the NaO and ethyl acetate solution to enter the plug reactor R1 and empty into the waste tank B3. Fourth, adjust P1 and P2 to give a constant flow rate of about 300 ml per minute at flow meter F1-01 and F1-02. Make sure that both flow rates are the same. Record the flow rates. Fifth, start monitoring the inlet Q1-01 and outlet Q1-02 conductivity values until they do not change over time. This is to ensure that the reactor has reached steady state. Sixth, record both inlet and outlet steady state conductivity values. Find the concentration of NaO exiting the reactor and extent of conversion from the calibration curve. 7. Open sampling valve V15 and collect a 50 ml of sample. Carry out a back titration procedure to manually determine the concentration of NaO in the reactor and extent of conversion. And lastly, repeat the experiment step 4 to 7 for different residence time by reducing the feed flow rates of NaO and ethyl acetate to about 250, 200, 150, 150 ml per minute. Make sure that both flow rates are the same. Switch off both pump P1, P2 and P3. Close valve V2 and V6. Next, switch off the heaters. Then, keep the cooling water circulating through the reactor while the stirrer motor is running to allow the water jacket to cool down to room temperature. Fourth, if the equipment is not going to be used for a long time of period, drain all liquid from the unit by opening valve V1 to V19. Rinse the feed tank with clean water. And lastly, turn off the power for the control panel. So, this is the result obtained from calibration curve experiment and a graph is plotted. From the graph, we can see that the conversion increases as the conductivity of the solution mixture decreases. It is because when the conversion increases, the concentration of sodium hydroxide decreases. The sodium hydroxide molecules reduce as it is converting to sodium acetate. The table shows the data obtained from the experiment on the effect of residence time on the reaction. From the table, the graph of conversion versus residence time is plotted. As the conversion increases, the residence time will also increases. This indicates the time taken for the sodium hydroxide molecules to convert into ethyl acetate. Referring to the graph, we can see that the residence time between sample 2 and 3 slightly decreased. It might be due to accidentally overdrop the sodium hydroxide solution into the sample during titration process. So for the recommendation, first, during titration, we need to be extra careful in controlling the number of drop of sodium hydroxide. Next, the flow rates of the inlet need to be kept constant by monitor in it at all time because the flow rates will affect the collected data. And lastly, repeat the trials at least 3 times and calculate the average result to get a more accurate data. Fatin Syukrina binti Muhammad Jufri. Nur Fatiha Murshida binti Zamri. Muhammad Alif Lukman bin Zalimi Syam. Nazifa binti Muhammad Syarawi. Raja Nur Hazikah binti Raja Badrul Hisham. Wani Wahidah binti Muhammad Yusuf. Thank you for watching.